Okay, so now that you got some background on error and uncertainty, let's go ahead and use it within some calculations. So let's say, for example, we are given the following example that we are trying to figure out the area of the fence given the following measurement. So we have really four pieces of information. We have the 6.7 plus or minus the zero point 0.3. Okay, so we have a length followed by an uncertainty in the length. And then also we have a width followed by the uncertainty in the width. So the first half of this is pretty straightforward. If we're trying to figure out the area, we're just going to multiply length times width. But now the question becomes, and that would be the 6.7 times 3.2. So now the question becomes, what do we do about the 0.3 and the 0.2? Okay, we know that we want to figure out a uncertainty in our area. So then how can we go about doing that? So before we get there, let's just kind of do a little bit of review. That if the 6.7 is my length, then my 0.3 is my uncertainty in my length. So the expression that I'd use is the delta L. And if the 3.2 is my width, then the 0.2 is going to be my uncertainty in my width, also known as my absolute uncertainty. And if I wanted to find my fractional uncertainty, my delta L over L, what I would do is I would take the 0.3 meters and I divide it by the 6.7. If I wanted to find my fractional uncertainty in my width, I would take my uncertainty in my width divided by the width, and that would be the 0.2 meters divided by the 3.2 meters. If I wanted to find the percent uncertainty, all I would do is multiply this by 100. Okay, so those are our three terms: absolute uncertainty, fractional uncertainty, and percent uncertainty. So how do we carry out the uncertainty within a calculation, also known as propagation of error? Basically, your calculation is going to fall into one of four categories. They're going to be, three categories. They're going to be multiplication, division, or exponents, addition and subtraction, and or trigonometry. Okay. So if we wanted to do multiplication, division, and or exponents, we would want to do the absolute uncertainty in the answer is the sum of the fractional uncertainties in each term used in the equation. So let's say we had the equation z equals x to the nth divided by y. If I wanted to figure out the fractional uncertainty in my z, then what I would do is I would sum the fractional uncertainties of each term. So there's going to be a fractional uncertainty in my x, and I'm going to add it to my fractional uncertainty in my y. The only thing that we also have to take into account is that this is to the nth power. So what we'll do is we'll multiply that term by whatever that value is, n. And that would be it. And if I want to get my absolute uncertainty, once we get a number from that, if I wanted to get my absolute uncertainty, my delta z, all I would need to do is if I want to get z by itself, I just have to multiply it by z. So I have to take my fractional uncertainty and then multiply it by my actual value. So looking at the above example, if that I have area equals length times width, then the change in the uncertainty in my area, my fractional uncertainty in my area, is going to be the change in length over L plus the uncertainty in my width divided by the width. So the fractional uncertainty in my length plus the fractional uncertainty in my width is going to be the fractional uncertainty in my area. So that's going to equal my 0.3 meters divided by my 6.7 meters plus my 0.2 meters divided by my 3.2 meters. And so when we add this together, and then actually what I'm going to do is I'm actually going to multiply this by my area. So cross multiply by that A. And my A I came up with was 21.4 meters. What I end up getting is a value, my delta area, my uncertainty in my area, is 3.08 meters, and my area is 21.4. So my final expression for my area is going to be 21. Okay, I'm going to round to 2 sig figs because each value had 2 sig figs. Plus or minus, and I'm going to round this to 1 sig fig, 3 meters. And that's going to be my final expression for the area of the fence with the uncertainty associated with it. So that's if we're multiplying, dividing, and or exponents. Well, that's not the only way that we can use uncertainties in an equation. We can also add and subtract. So by looking at this, if I have a term z and z is equal to x plus y, what I'm going to do, the difference here is I'm not adding the fractional uncertainties, I'm adding the absolute uncertainties. So it's just a straight of your uncertainty in x plus your uncertainty y. If you have a multiplier in front of it, like the 2 here, then it's just dealing with the same thing as the exponent. You got to multiply it by that value. So it doesn't matter whether we're adding or subtracting, we're still adding the uncertainties, the absolute uncertainties. So if a rectangular pen has a length, okay, so there's our pen, of 54 plus or minus 3 meters, and it has a width of 22 plus or minus 2 meters, then the perimeter of the pen is 2 times the length plus 2 times the width. So that is 2 times 54 plus 2 times 22. 2 times 22 is 44. 2 times 54 is 108. So this is 108 plus 44. And so that adds together to be 152 meters. Now the uncertainty in your perimeter is 2 times the uncertainty in your length plus 2 times the uncertainty in your width. Okay, and these are, once again, your absolute uncertainty. So 2 times your 3 plus 2 times your 2. 2 times 2 is 4, 2 times 3 is 6, 4 plus 6 is 10 meters. And so I'm going to write my perimeter as 152 meters, and this is to 1 sig fig already, plus or minus 10 meters. Okay, and that would be my final expression. And then last but not least is if you're dealing with trig functions. And so basically the idea here is you're going to find the maximum value and then the minimum value that it could be, and then subtract those two and then divide by 2. So if we're trying to find your uncertainty in cosine theta, what we want to do is we want to take cosine of the angle, so in this case 30, and we're going to add the uncertainty plus 5 degrees, and then we're going to subtract cosine of 30 minus 5 degrees, and then we're going to take that all and divide that by 2. So this is cosine of 35 minus cosine, and actually I'm going to put the absolute value around here because we're just dealing with uncertainty, so it's plus or minus. And so if you work that out, I got a value of 0.044. So I would round this to 0.04. And since this is cosine, this is a unitless number, so I don't have to worry about that. All right, so let's set up the next example here, and actually you're going to finish this for your rest of your homework, and then we're going to kind of compare answers in class. So my mom has a dog, Ginger, and yes, she is from Brooklyn, so it's pronounced dog. So I want to know what is the density of Ginger. So I take some initial data. So I have a cylindrical wastebasket, and it's got a height with some uncertainty. It's got a radius with some uncertainty, and I measure the mass of Ginger just with some uncertainty. So we want to figure out the density, and there's that value of rho. Okay, so it's just the letter that we use in physics for density. And you know from your chemistry class, density equals mass over volume. So we have the mass, we're done, but now we have to kind of think about how can we calculate the volume of a cylinder. So if we know that area, which is just pi times the radius squared, and then we multiply that by the height, then we should be able to get a term for volume. So the density is mass over pi r squared times height. And that's going to be our expression. So what I ask of you to do for the rest of your homework is first calculate the dog's density, then find the fractional uncertainty in the dog's density, Ginger's density, and then find the absolute, and then let's write the final value. And I have some reflections at the bottom here. So finish the rest of this for homework, and we'll compare answers tomorrow. And that's all for now. Thanks for listening. Take care. Good night.